I mean, we can do more in the
Okay.
file of it, but yeah.
Okay. So question number two: two ships A and B are going with the constant velocity. The velocity of A is given to us. Velocity A, they have given 312 kilometer per hour, and the velocity of B, it is P and Q. Find the speed of A. So this part is, I think, easy. Speed is simply the velocity of A magnitude, which will be square root of 3 square plus 12 square, which will be 140, 153, square root 153.
Yeah, it's like 14 something. Wait,
Hmm.
uh,
Less than 12, 12 something, 12.4 or 5 or something.
12.4. Yeah.
Hmm. Okay. The ships are modeled as particles at 12 known. So the time is given to us 12 known. A is at the position vector. So they have given you OA, the initial position vector. It is minus 9, 6. And B is at the point with position vector. Okay, they have given you OB as well. 16, comma 6. At T time, T hours after 12 known, they have given you the AB vector. Okay. Find the value of P and the value of Q. So you will have to first of all find this vector. And then you will compare the things, and then you will get the value of P and Q. So they have given you the vector AB. So AB vector will be equal to, they have given you AB, it is equals to 25 minus 12t and minus 9t. And we can find AB ourselves as well. AB means the distance between A and B, which will be equal to, if you break it down, what will this become, Mahad? If you break it down in the terms of position vectors, AB will open up into
Uh, OA minus OB or something.
Yes, you're close, but Azim, what about you? How will you open it up? Forgot. Both of you forgot it. OB minus OA. The position vector of the
Did I
second.
say OA first? Sorry, yeah.
Yes.
I meant OB. Okay. So, yeah. Second one minus first one. Okay.
Yes. Don't forget this. It's important. Azim. Okay. Azim is there or not? He is there. Okay. So this means after TR. So this means that they're talking about the new position vectors of OB and new position vector of OA. So new OB will be equal to the old OB plus the velocity of B times time. Same will be the case with OA. The new OA will be equal to OA old plus the velocity of A times time. So now OB old is given to us. OB old 16.6 plus velocity of B is PQ time minus OA old is minus 6.9 or minus 9.6 plus velocity of A is 312. And now you can compare this one with this complete thing, because the left part is given to you and the right part you have found it yourself. So after simplifying this right part, this would become 16 plus TP and plus 9 and minus 3T. 6 plus TQ minus 6 minus 12T. After comparison, let's see what we have. So 25 plus 9 will be, sorry, 16 plus 9 is 25 plus If you take t common, you will get p minus 3. And 6 minus 6 would become 0, plus if you take t common, q minus 12. So after a simple comparison, this is 12t, sorry. After simple comparison, you can see the coefficient of t in the x coordinate and the coefficient of t in the y coordinate. So this means that minus 12 is equals to p minus 3. So your p comes out as minus 9. And minus 9 is equals to q minus 12. So your q comes out as 3. Okay, got it? Find the bearing of A from B when the ships are 15 kilometers apart, giving your answer to the nearest degree. 15 kilometers apart. So this means the magnitude of AB, it is 15. So now you know the complete this AB vector is equals to 25 minus 12t minus 9t. So if you find the magnitude, you know, this would be if you
Yes.
square root of 25 minus 12t plus minus 9t square is equals to 15. If you square on both sides and then expand the left part, you will get 625 minus 600t plus 144t square plus 81t square is equals to 225. I moved the square root on the other side. So 144t square and minus 519t and plus 400 is equals to 0. What do you want? Find the bearing when the are 15 kilometers apart. Okay. First we will find the vector. 144 minus 519, 400. This doesn't seem. Let's check the working. 25 square is 625. Good. 2 times 12 times 25. 600. And 12 square 144. And 81t square. Look. Minus 9t whole square will be 81t square. So this would become 144 plus 81. 225 t square minus 600t and minus 400 plus 400 is equals to 0. So your time is coming out as 4 upon 3 and the other one is also 4 upon 3. Both answers are same. 4 upon 3 and 4 upon 3. So this is your time. And so if you put in the value of if t is equals to 4 upon 3, your AB vector will become 25 minus 4 upon 3 will be 25 minus 4 multiplied by 4 and 16, and 25 minus 16 is 9. And minus 9 multiplied by 4 upon 3 is 12. Right? Let's check. 25 minus 12 multiplied by 4 upon 3. 9 minus 9 times 4 upon 3. 12. And negative 12 because we have a negative 90. And now the vector from A to B. It is 9 positive. So let's suppose this is your A. So 9 positive and 12 negative. So here is your B. This is the vector. And they are asking you to find the bearing of A from B. So A from B means this is your B. So the from means the north will be on the B. From B. And they are asking you to find this angle. This is the bearing. So if you find this angle, theta, and then you subtract it from 360, you will get the bearing. So this angle would be tan inverse of tan theta, opposite upon adjacent. So theta will be tan inverse of 9 upon 3 upon 4. And degree is 36.9. To the nearest degree. Okay. 36.9. And then 360 minus 36.9. 323. Okay. 7 marks. Easy 7 marks. Okay, so they have given you the velocity vector. So find the speed of P when time is 2. So velocity of P at time 2. So when you input the value of T as 2, you will get 7 minus 10. And 12 times 2 minus 20. So 7 minus 10 is minus 3. And 12 minus 20 is 4. And so the velocity, sorry, speed will be equal to 5. Square root of minus 3 square plus 4 square. So 5. Then find to the nearest degree the size of the angle between the direction of motion of P. The direction of motion of P and the vector J. So if we talk about only the velocity part, so it would be equal to velocity of P is equals to, direction of motion when time, so when time is 2, okay. So the velocity vector when time 2 is equals to minus 3, 4. So the direction is in the x, negative x, minus 3, and then plus 4. So this angle, this is your velocity. And they want the direction between the direction, angle between the direction of motion of P, so this arrow that I made, and the vector J. Vector J is the y axis, vector J. So they want this angle, theta. So that will be equal to tan inverse of, if you find this angle and then you subtract it from 90. So theta will be equal to 90 minus tan inverse of 4 upon 3, opposite upon adjacent. So 54, 53 point, this would be equal to 36.9. When your time is 2, so nearest degree. So 37. 90 minus tan inverse of 4 upon 3. 37. Okay?
Yes, sir.
Hazem, all good?
Yes, sir.
Okay, good. The constant acceleration of P. Find A in terms of, okay. Yes, okay. Velocity vector was given to us. 7 minus 5t and 12t minus 20. If you separate it, this will be equal to 7 minus 20 plus minus 5 and 12t. So the new velocity vector is equals to old velocity vector plus acceleration vector times time. So this means the acceleration vector is 3 marks for this thing. I don't know why. So you've got the answer. Minus 5i plus 12j in terms of I and j. Find the value of t when t is moving in the direction of the vector. Okay, look, is moving in the direction of the vector. Direction of the vector. They have not given you the velocity of p. They have given you the direction of the p's movement. So this means the new velocity vector of p will be parallel to this vector because both have the same direction. They're talking about the direction. They're not exactly same. Okay, we don't know if their size is also equal or not, but we know that they both are parallel to each other. They have the same direction. So that's why whenever two vectors are parallel, this is what happens. So now they are scalar multiples of each other. So new vector 7 minus 5t minus 20 plus 12t is equals to minus 5k and 8k. And now you will solve them simultaneously. So 7 minus 5k plus 5t and minus 20, 8k minus 12t. Use your calculator to solve this simultaneously. You will get the value of k and t. Minus 5 plus 5, 7. 8 minus 12 minus 20. So your k is coming out as 0.8 and your t is coming out as 2.2. Find the value of t. So we have found the value of t. I think the most difficult question we did in the first class of vectors. After that question, all of them are pretty much simple. Okay, look at this one. 10 marks. Second, okay. Yes, at time 4 seconds, bird B is southwest of bird A. So then what did we do? B is southwest. This is your southwest direction. At a bearing of, you can say, 225. So you found the direction vector. Direction vector in this southwest direction. So we know the angle, it is 45. And we found a unit vector, you can say, unit vector. So we converted this into components. So this would be negative 1 cos 45 because it's alongside the angle. And this is negative 1 sine 45 because it is downwards. So this is the unit vector in the southwest direction. And then we knew that this is parallel to, right? This is the direction only. We don't know the size is equal or not. So that's why we set it to k times the unit vector. It is a scalar multiple. So whenever the direction is same, it doesn't matter. It doesn't tell you that the size is also the same. So that's why to cater that, we put in this scalar multiple. We don't know how much bigger or smaller it is than the direction, but direction would be this one. And it is k times the other vector to which it is parallel, has the same direction. So BA, that B is southwest of A. So B is southwest of A. So that this is your A. So B is southwest of A. So that's why I said it, look, this is parallel. So A and B is also like this. And this is the unit vector in the southwest. So we don't know if the AB vector is bigger or smaller, how much bigger, but the direction is same. So that's why we said it like this: scalar multiple of the unit vector in the southwest direction. And then we opened it up. BA is equals to OA minus OB. And then we formed their new position vectors and then simplified, calculate, and move things around, solve it simultaneously, and got the answer. This was a good question. You can try this again as a practice.